Comes out of section 7.3, derivatives of other trig functions. We found in our last lesson that the derivative of sine x is cos x, and we found that the derivative of cos x is negative sine x, and those can be proven with various, with limits, first principles, even looking at the graphs and drawing tangent lines and kind of prove it to yourself. But you'll get that on a formula sheet. It's not something you need to memorize. You will also get, what's the derivative of y equals tan x, but let's just take that for a second and realize, okay, I know what tan x is. It's sine x over cos x. I should be able to take this derivative just by using the quotient rule to say, okay, it's the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. And what you end up with here is cos squared plus sine squared on the numerator divided by cos squared. So 1 over cos squared is the derivative of tan. Most formula sheets will say that as secant squared, because that is the same thing. So you'll get this again on your formula sheet, that the derivative of tan is secant squared. And you can go about it and prove, a bunch of these to yourself. The same thing for the derivative of cotangent x. The steps are almost identical, and you'll find out kind of a similar answer, but negative cosecant squared x is the answer to that one. So you can try that with quotient rule and prove it to yourself. The same idea for, let's say I had y equals secant x, and they say, what's the derivative of that? Well, that is 1 over cos x. So you can treat it as a quotient rule again, or you could even just say that's cos x in brackets to the minus 1. So the derivative of that is going to be negative 1 cos x to the negative 2 times the derivative of cos x, which is negative sine x. And so those negatives cancel out. You basically have sine x over cos squared x, which is a good answer. For whatever reason, most formula sheets decide not to write it that way. They write it as secant x times tan x. I guess looks slightly simpler. But so the derivative of secant is secant tan. Same exact kind of steps, and you could prove to yourself that cosecant x, if you took the derivative of it, you get kind of a similar answer. Again, it's negative, and it's negative cotangent times cosecant. So you can try those steps and make sure that that all shakes out for you. So let's try an example where we're asked to differentiate something that's not just on the formula sheet. So we've got the function here, y equals 1 over 1 plus tan x, and we're asked, what's the derivative of that? Well, again, you have the choice of saying, well, let's call it, 1 plus tan x in brackets to the minus 1, and then doing it with a chain rule, or doing it with the quotient rule right off the bat. But either way, your answer should look the same in the end. You're going to get, we have to multiply by the derivative of tan, which is secant squared. And so basically you have negative secant squared x over 1 plus tan x in brackets squared. That would be an acceptable answer. You may also see that as negative 1 over cos squared x times 1 plus tan x in brackets squared. So you could do various things to simplify that, but you could use that now to find slopes of tangent lines and all the things we've used derivatives for in the past.